Welcome, good morning. Welcome back to the OpenShift TV coffee break. Today we have a super guest that we will present in a moment. Before going into our guest and our topic, I would like to say hello to Fabio. Hi, Fabio. How are you?
Good morning, guys. Hi, Natalia.
Morning.
Nice to see
Morning.
you again after summer break.
Yeah, we come back after summer break. So just a quick reminder, this is the OpenShift TV coffee break, a show we do here in EMEA, talking about the whole OpenShift, Kubernetes, cloud native architecture here at OpenShift TV. And today's our special guest is Ian Lawson from Red Hat UK. Ian, do you like to introduce the topic of today?
Hi guys, it's nice to be back. Name's Ian Lawson. I'm a domain solution architect at Red Hat. I focus primarily on OpenShift. But in a previous life, I was involved with artificial intelligence programming. It's what I did at college, what I did my PhD in. And today we're going to talk about some really nice, cool things you can do with the new Knative serverless technology around the concept of AI and machine learning, and why I think it's probably the best tool set you can currently do to do these kind of things.
Sounds great, Ian. And could you please remind to the people what is Knative and why they should why they should care about Knative in their OpenShift Kubernetes life?
Well, I'd say Knative is the coolest technology in OpenShift by far, and I'm a bit biased because I love it to pieces. Basically, the concept of Knative is and it's quite, I get told off at this point because Knative refers to something called serverless, and I hate the term serverless. I think it's a ridiculous term. It's someone else's server. I always refer to it, I'm talking to customers, as the unicorn's bottom because, it doesn't actually exist. But what Knative serverless actually does is it allows you very simply to scale your applications down to zero. And that sounds really weird. Why would I want to turn my application down to zero? Well, let's take an example of this. You've got, let's say, an application made of 5 microservices. One of those microservices is called once every 200 milliseconds. The other 4 are called once every 24 hours. Now, if you're standing up those microservices in standard Kubernetes, standard OpenShift, they have to be resident. They have to be running, and they have to be able to receive traffic. If traffic comes into the cluster and the pod isn't there, you get a failure. What Knative Service allows you to do is to actually set these applications to reduce themselves to 0 replicas when they're not being used. So what that means in English is that they're not consuming resource. They're there, they're registered, they're waiting for traffic, or in other cases, they're waiting for events to trigger them to actually respawn up to 1. But it makes for highly efficient systems. And what we're going to talk about today is a little idea I've been working on for a couple of months in my spare time, which is the concept of what I call atomic decomposition. And what that entails is breaking down systems to their smallest atomic components, and then actually instantiating those individual components as Knative serverless. And what's really cool about this, if you can imagine this, having an application, but that application is made up of 100 services that only appear when they're being called. So you have much smaller footprint for your applications. You need much less kit. And, talking about the green agenda, it's much more efficient in terms of the power consumption of your servers. Does that make sense?
Yeah, yes, it does. And probably can we tell that the Knative technology decouple in a very effective way that the development phase of an application from the way that application uses their infrastructures. So
Absolutely.
AppDev people doesn't really need to worry about how effectively the underneath infrastructure is used, which seems just a green statement, but it is not at the end. So it's a very wise way to use what you have underneath, whatever kind of OpenShift or Kubernetes release you have.
Yeah, it's a fantastic point. One of the things that I love about it, especially from an OpenShift perspective, is that to make something Knative serverless, you simply tick a box on the user interface. There's no additional code. There's no changes for those kind of things. In fact, we've got this fantastic functionality, and I'll show you an example of this later, called Knative Functions. And I'm a big fan of this, and I'm really surprised that the industry hasn't jumped on board with this. Now, Knative Functions are basically an extension of our source-to-image build approach. So what you can do is you can rack up to your laptop, produce some source, get a Git repo, and then point Knative function at it, and it'll build the image set up the image, wire the image into the actual cluster. So all the kind of things you have to do to make it a Knative service are under the covers in the Knative function command. And all you do is just rack up there, you choose which builder image you want to use, and you provide your source. And that's a really nice way for developers to be able to get on board with the Knative stuff, because it, as you say, it doesn't actually require any knowledge from a development perspective. There are a couple of caveats I'd add to that, though. The first one is that you should write sausage machines. And I love saying that because the concept of a sausage machine application is something that has pure dependency injection. So you have nothing in the application that understands state. Everything is provided to it. And that's one of the key features of Knative Serverless that we're working on at the moment, is that Knative Serverless can't use persisted volumes because the overhead of basically reattaching these persisted volumes every time you spin up the pods, spin down the pods, is way too much. So what we tend to do, especially when I'm writing these kind of things, is I write little sausage machines. And I'll go into this when I'm talking about the little project I'm working on. But the Knative services themselves, they actually use an external persistence mechanism that isn't attached directly. So in my example here, I'm going to show you what I'm doing is I'm using Red Hat Data Grid in Finispan, which is an in-memory data cache. So what happens is the application pops up, it gives its ID to the actual data grid, it pulls its data state back, it works on the data state. When it's finished, it pushes the data state back into the data grid, then it goes away. And that's the beauty of it. And I tend to get overexcited about it because I wanted to write this kind of system 20 years ago.
Yeah.
And we didn't have the technology then to do it.
We do have already a question from one of our attendees, test 1G21. So first of all, thanks for question. And he or she anticipated my question is, can you please give us a real life customer use case on Knative? How are customers using it in their environment? A great question. Yeah. Real life use case. And
yeah, well, here's a good one. So say you've got something like a department that deals with license plates. So in the UK, we've got DVLA who deal with license plates. Every year they release a new tranche of license plates. So during the year, their systems are low loaded. And then when it gets to a certain point, midnight on a certain day, it goes bananas. It goes like 1,000, 10,000, 100,000 times more processing required. If you were doing it in Knative, what you could do is stand up those services to actually process the license plates, process the postcodes and all those kind of things, and have them offline until they're needed. So that's the kind of use case. And a more appropriate use case from a kind of the green agenda perspective is that you just need smaller clusters. You know, if you want to stand up a system that's 10 microservices or 10 web services in a standard Kubernetes OpenShift system, they have to be resident the entire time. So they're sat there on the cluster, actually ticking away, consuming resource, you know, pinging their health checks and all these kind of things. And they're not actually doing anything of consequence. All they're doing is burning electricity. So in a Knative approach, you've got the situation where you can make these things go away. It's all about efficiency, to be honest. So is that a reasonable use case?
Definitely, yes, it is from my point of view. Or generic image recognition services. When you just need that service, when you have to recognize some images, I think CCTV camera, stuff like that, instead of instantiate 100 instances of the specific services, we'll let the underneath Knative intelligence to instantiate just the right number of instances whenever they are needed.
Yeah, that's on demand and taking benefit from the scale to zero approach, right? Yeah, and I also have two questions. One is conceptual, let's say. Are those atomic decomposited unit, in your opinion, are those function or microservices? What is the, you're talking about atomic decomposition. What is the atomic object? It's a container, right? But is it a function or is it a microservices? What is it?
That's actually a deep philosophical question.
A monad, like Leibniz monad.
It's way too early in the morning for that kind of question. From a perspective of the technology, it could be anything. So you can have things like, for example, using Quarkus, you can have a Spring Boot app. You can have a massive full fat Spring Boot app doing this kind of thing. When I talk about atomic decomposition, it's kind of where I see the next generation of development going. And I would want to see right down to the function level, the smallest possible atomic component. Because if you can break those into the smallest of components you can, it makes your applications very agile. It makes your applications very easy to change. You can change a very small component of it with no impact upon the rest of the actual system whatsoever, as long as you're adhering to a standard interface. And so that's one of the nice things about the Knative serverless is that, and I'll get onto this when I talk about the eventing side, we have this concept of what we call cloud events. And cloud events are basically very, very simple, very beautiful little components for eventing. Basically, all they are is a type and a payload. So you don't have the overhead of having to learn a format, all these kind of things. We have a situation with Knative eventing, which allows you to trigger the creation or the recreation of these applications based on the arrival of one of those events. So for me, to answer your question very quickly, if I was doing it and I had a full greenfield, I would get everything down to the smallest possible atomic component. And that's the point of my idea that I've got. I'm actually, I'll give you a quick overview of this. I'm obsessed with neural nets. Always love the concept of a neural net. If you don't know what a neural net is, it's what's in that piece of jelly that sits in your skull is a one big neural net. And a neural net is made up of these tiny little things called neurons. And all a neuron does is it sits and waits for inputs, and it puts those inputs together. And if those inputs exceed a certain threshold, it will send an output. And that's all a neuron is. And everything you do, when you speak, when you think, your memory, how you move your muscles, all those things are driven by combinations of these tiny little atomic neurons. Now, what I'm thinking is, well, why don't we model that? We could use Knative serverless. We can build these neurons. We can use cloud events to actually provide the inputs and then write the functionality within the neurons themselves to aggregate the information you're getting from the cloud event. And then, and this is where it gets beautiful, emit further cloud events from your neurons based upon the input you've got. And you can build these massive, complicated systems from very, very small atomic components. It's a brand new way of thinking. It's a completely different way of thinking in terms of coding, because you're talking about aggregation of outputs and stuff like that. But I love the idea. And it's one of those ideas that sticks in your head and you think, this could be good, but how the hell do I do it? And it's only since I've been looking at Knative serverless and the cloud eventing that it's just gone, this is perfect for it. Did I actually answer the question there?
Yeah, that was great answer, and it's also introducing the title of this episode, Next Generation AI/ML, and we're talking about serverless. So I think we gave the context why serverless and AI/ML, because we're going into this model, as you say, like a neuronal architecture based on neuron nets or neural, those kind of architecture. But I was wondering if you were thinking about using existing pattern for those architecture, like a common AI/ML pattern, or is something from scratch?
This is actually something from scratch, and the reason it's from scratch is I've done a lot of work with customers. I did a lot of work in the past with AI and machine learning projects. And the thing with AI and ML is that you end up doing the same thing over and over again at scale. That's it. With MapReduce and stuff like that, you get these massive data lakes, Hadoop data lakes, and you're rerunning experiments over and over and over again. The experiments themselves are often quite simplistic. The output is quite complicated. And they've got into patterns of how they produce these applications. And that's why we've got MapReduce. That's why we got Spark and all things like that. And looking at that, I was thinking, well, it's very limiting. It does what it says on the tin. You can do some fantastic experiments with it, but it's a very, very blunt force trauma way of actually writing code and dealing with this kind of data. And I was thinking, well, is there a better way to do it? And the better way to do it is to remove the complexity entirely. It's all about simplification at the end of the day. And let's say I'm going off on a philosophy here, so stop if I start ranting. But
it's interesting, actually.
I think we've all got a little bit tied up in the recent years with becoming complicated. All of our frameworks are complex. All of our tools are complex. And when we write code, we spend 90% of our time, tinkering with the config on the frameworks we use, and 10% of our time writing the code. And that to me is the balance is wrong. You know, we shouldn't be actually being experts on Maven POM files. I hate Maven POM files. I've spent too much of my life in my head.
Do you like Gradle? Do you like Gradle DSL?
It's unfortunately I like Ant. And
oh,
that's showing
old glorious Ant.
my age a bit. I find Maven tries to be too helpful and isn't. But my point is really that we spend too much time getting tied up with the complexity of the frameworks, and we should be focusing on the pure code, on writing the functionality itself. If we go down this approach of actually producing atomic components, then using Knative serverless to framework it, number one, we don't need to write any code from a Knative serverless perspective. We can just write our tiny little atomic components that do what they need to do in the best way they can. The only pattern I've been using, and the pattern I've been using is because of the stuff I talked about with PVs. You can't have persisted volumes currently attached into the pods. So if you want to do things that persist over the duration, past the duration of the call of the function, you have to have external persistence. So what I've been doing is I've come up with this idea where the actual neurons themselves are completely utterly stateless. So you provide everything to the neuron. And what I'd like to do going forward, this is where it gets a little bit cooler. I'd like to provide the code for the neuron as injection as well. So you write a neuron, and the neuron is just basically a code executor and a persisted volume, or let's say a data grid communicator. And you provide the algorithms into the neuron and the ID for the neuron itself. And the neuron goes to the actual data grid, pulls its information, applies the algorithms. If it has to push cloud events afterwards, it will. And then it pushes its sort of finished state back into the data grid. And suddenly you've got the ability to actually code away from the neuron. So I haven't worked out how we've ever do that, because I don't want to go down the route of writing my own programming language. But there are some very cool things coming. Again, going back onto the OpenShift side, there's some very cool things coming with Build V2, which people are probably aware of. So we're upgrading our build processes within OpenShift. We have this fantastic thing called S2I, and I'll tell you a naughty little story about that, because it used to be called STI back in the days. So I used to go into customers and talk about STI, you know, source to image and all these kind of things. And most of the customers would laugh at me, and I couldn't work out why they were laughing. And of course, STI stands for sexually transmitted infection. So I was going in and talking about OpenShift, and I was saying, well, you want to bring this sexually transmitted infection and use this sexually transmitted infection. So I actually raised an RFE, said to the Americans, said, could we please change it to S2I so I don't get laughed at? But anyway, Build V2.
Oh, so the name changed thanks to your suggestion? Oh, that's nice anecdote.
I got quite cross about it, because I got sick and tired of being laughed at by military people when I was doing presentations. But what we got coming is something called Build V2, which is based on something called Shipwright. And what Shipwright does is it actually produces something called build packs, which have all the framework images you need to build the actual appropriate source code, and you just provide the source code. Now, the difference is under the covers, these build packs get executed within your namespace as opposed to being executed at the root level, which we don't like within OpenShift itself. But it means that you can provide your own build packs and stuff like that. So I was wondering going forward, I've been talking to the Knative people about this, about whether we can have the situation where you run a Knative service that actually executes a build pack to build your source material there and then executes it. And it builds it on a code change. So you don't build it every single time. So it'll be sort of, you know, you point at a Git repository, you point at a build image, the build image is used, it produces the image, it executes the image, Knative serverless, goes away, comes back, pop, there you go, fires it up a pre-existing image itself. Does that make sense? Well, I've gone off topic slightly.
No, that makes totally sense. Yeah, and I wanted to ask Ian, you described this automated mechanism for building the function, no? So Shipwright, Build V2, and then there's the Knative function. Do you think this is coming more and more close to AWS Lambda or those public cloud, function as a service, or is still there's something missing still there?
I say it is. I mean, I don't think we're ever going to reach the level of Lambda, because we don't have the hardware. We don't have the ability to spin up these multiple functions and let people get at them. But what I'd like to see us get to is similar to the stuff we got with Tecton Hub and the Operator Hub, that we have a situation where if we go down this route of producing Knative serverless, let's say neurons or neuronic programming or something like that, We have a hub where people can actually push their images or their source code for building these individual, really small components. And then what you could do is have like a sort of marketplace where you can go and say, well, I need a Boolean aggregator. I need a face recognizer. I need a textual analyzer. And you can just pick the actual components off you like. And you can pick the source material and push it into a build pack as part of your deployment mechanism for the Knative serverless. And then suddenly you're almost at the Lambda point, but instead of having, because in Lambda what they do is they have existing systems up and running with these functions ready to call. You just subscribe and you call a Lambda, it goes into Lambda, does it, comes back with the response. Their approach is not efficient. It's not green because they've still got those Lambda, even though it's serverless, they have to be still running those functions 24/7 for you to be able to connect to. Knative serverless is actually better because those things are available to you, but they're offline when you're not using them. So they're not consuming system resource. So I think personally that Lambda should go more the Knative serverless way, but I might be biased.
That's a good answer.
I am as well.
Yeah. Yeah. So I'm aware I haven't actually shown you any demos yet.
Yeah, please. I'm pretty curious to see.
Show me the code, dude.
Sure.
As we used to say.
So if you can see my screen now, what I've got here is, and it looks very cluttered, and I apologize.
Sorry, Ian,
to
interrupt. Can you just magnify, please? Just a little bigger.
So I don't want to lose the
yeah, right. Okay, that's okay.
Going on here.
Fine.
And I'll explain why there's too much going on here, because one of the nice features of OpenShift is when you install an operator, instead of installing the operator across the cluster, because you can do that, which means everyone on the cluster then has access to it if they've got the appropriate RBAC. What you can do is you can run operators locally within the namespace, so only you have access to those extended objects. So when you're looking at this application here is actually quite simple, but I'm running, for example, the CamelK operator because I'm using some CamelK, which is a fantastic integration technology. And I'll show you the source code for that because it's tiny and it's really, really sweet. I'm also running what's called the InfiniSpan operator, and that gives me data grid. So I'm running basically a neural net as an instance of data grid. So it's a named instance of data grid, and I'm using it, and I'll explain how I do it in a minute to get around that problem I have with the persistent volumes. But I want to show you something really sweet first of all, and that's this thing here. So what I got here is what's called a broker. Now a broker sits within a namespace, and it acts as a hub for the cloud events. So those cloud events I told you about are basically little packages that can be thrown out to force Knative serverless components to start. Now, what's beautiful about it is this. Number one, these are namespace bound. So I've got one called default, and I can refer to it by the namespace. So I can refer to it as, for example, serverless demo.default when I actually refer to the broker. What you do is you set up what's called triggers. So a broker has a number of triggers, and those triggers are looking for events of a certain type. Now, in this case, I've got a trigger here. If we click on it, this is actually looking for a type tech talk event with a subscriber of event reader. So there's a Knative service called event reader that's waiting for an event to arrive called tech talk event. I've got another trigger here, which is waiting for a type Quarkus event, which is linked into a Knative service called Quarkus function. Now, these services are just the endpoints that do the actual action of spinning up the application if it doesn't exist, or ingressing the traffic if it already exists. And what I've got is a Quarkus function. So Quarkus is our brand new spin of Java that makes Java finally cool. Java was always cool. It's just, I still think Java's new. So when I'm talking to people who use Node and Go and all those kind of things, they make me feel 50 years old, which I am. But Quarkus actually makes Java efficient. It makes Java extremely fast. So it's very well suited for the use in Knative serverless. So I've got a Quarkus function that's waiting for a Quarkus event. And what it does is quite sweet. When it receives that event, it logs the information it gets, but it emits an event of type tech talk event. So when it receives that event, it emits an event of its own back into the broker. The broker then looks at the triggers and will kick off this CamelK component, which then processes that event. It's a very pithy example of this, and it's kind of the basics. But what it does is it shows you that you can actually link together these individual small components by an eventing model that controls the Knative serverless. And that's very, very sweet. Now I've got, if I move it around slightly, I've got something here called...
That's a great example how Knative fits perfectly event-driven based architecture application. So thanks for introducing the concept.
It's a pithy one, but it kind of sums up how cool it is. And what I've got here is basically I wrote a cloud emitter app. So what this is basically, I go to the URL. It is, I have to apologize. I haven't written a style sheet in 25 years. So this looks a little bit old school because I don't like CSS. What this actually gives me the ability is to actually emit an event, because an event is basically an injection of an event into the broker. And under the covers, it's actually a post. It's just posting an event. So what I'm going to do here is actually, that's the target broker. So I'm looking at the default broker in the serverless demo namespace. And I'm going to send Quarkus event. It's going to have just some random stuff in it, like say payload, podcast. When I emit the cloud event, what this will do is actually throw it into the broker. And everything's abstracted, so that's just thrown into the broker itself. So when I emit it, I'm going to pop straight back to the page, and you'll see, if we go back to the page first, currently, we've got a situation that the Quarkus app is scaled down to 0, so there's no instances running. And if I look at the metrics, you'll see there's no resource consumption going on. And this one over here, the actual camel K is running at 0 as well. Very quickly, before I kick it off, I want to show you this because this is very sweet. So is that big enough? Can people read that?
If you can increase a little bit, it's better.
Okay, bear with me 1 second.
Right. Okay. Thanks.
Just got to get on my page. So,
and we have appreciation from the chat. People like your dark OpenShift mode, and some people is attending from Sydney. So great. Hey, thank you.
Thanks for joining from so far.
Yeah, I'm going to destroy all the kudos we've got right now and say that the dark mode is on by default, and I can't work out how to turn it off. Although I do like dark mode, but it gets confusing. That's actually a 4.11 feature, and you can turn it off very easily. It's just I haven't found out how to do it yet. So I've actually got a piece of Java here that I'm using for my camel K, and I'll show you how simple it is. I'll highlight it so you can see it. And it's a very pithy one because all it's doing is it's logging the actual body it's getting from it. But it's using a from statement, knative : event / tech talk event. And just by using that, that will actually create a trigger when I install this as a camel K. Camel K is basically a Knative version of camel. And you can see how simple it is to actually link this piece of processing into the triggers themselves. And I was very impressed by how simple it was, just one line of code to actually link it in. But if we pop back to the thing over here. So what I'm going to do is I'm going to throw an event and jump back very quickly because things happen quickly. So I'll emit it, I'll pop back. You'll see the Quarkus event actually spins up immediately. So what's happening now is it's spinning up from 0 because it's received traffic. The Knative serverless functionality is now spinning it up, it's executing, and you can see while I'm talking, because I'm not talking quick enough, that the camel K has already spun up. So what this has done, if we go into the logs, you'll see that I've received this, and then I've emitted that tech talk event. If we pop back to the topology and then pop into the Knative, the camel K one, you'll see that I received a message that was created from the Quarkus function. Now, if we pop back, and I'll talk while it's happening, how it happens is when these things are actually spun up, a timeout starts. And if no traffic ingresses into this point or that point during the timeout, and they're on a function by function basis, these functions will auto-scale themselves down to 0. Now, that's the beauty of it. You know, they sit and they wait. They have a timeout period during which if additional traffic comes in, you don't have the overhead of re-spinning it back up and doing all those kind of things. But after, they go away and the resources go back into the pool. They're not being consumed. That one's now going. You see, this one's now scanning down. This one's scanning down. So they're actually terminating down to 0 again. What's lovely about this is you can also scale the other way. So when you set these Knative serverless up, you can actually specify sort of network traffic that will cause it to upscale as well. And we did this as part of the Summit demo, because what I wrote the back end of the Summit demo to do with the Battleships game, if anyone saw that. And it was all based around Knative functions. And we were pushing like 1 million events in to see what would happen. And of course, the clusters were just stopping. So what we did was we actually used the functionality within the Knative serverless to get these to scale up to 1,000, 10,000 replicas under network load. And that's the beauty of it. So you not only have the ability to scale up to 1, scale down to 0, you also have the ability to cope with burst compute if you happen to have a huge amount of stuff coming in. And that's why you need to think, when you're actually writing these things, of making them the sausage machines, the stateless engines. So you can have multiple replicas. There's no kind of transactional dependency within the actual functions themselves. There is a link that I passed over to the guys. Basically, I go through the whole sort of study of what this is about, my first neuron atomic AI principles. And this is talking basically about what I'm doing above and beyond the standard things with this approach. So that was a very, very quick demo. Any questions so far, guys? I'm aware I'm just slamming information left, right, and center.
So it looks very, very cool. I like this the way that everything is auto-scaled through an event. And to be honest, I like the OpenShift topology, because you can have a visualization of event component. In this case, those are your decomposed atomic unit, if you will. I have a question. What is this Dev Epiphany? Is your blog? Or
yeah. It's. I produced a blog basically full of stuff because I don't understand things. So when I don't understand things, I simplify them down to the point at which I can understand them. And then what I do is I write a blog on it. So there's blogs on here around Knative Serverless, Argo CD, OpenShift virtualization, the new KCP stuff. Every time I come across something that interests me, but I don't really understand it, I will dumb it down so I understand it and write a blog on it.
So you apply the microservices pattern also to your approach when you start to learn something. That's a good suggestion. Yeah.
Atomic decomposition, and the thing is, as you get older, you need to do that a lot. Yeah, so
that's great.
I've been working on using Quarkus to write operators in Java. So that's something else I've been playing with.
I like the name Developer Epiphany. So it's something really cool.
I want to show you something else very quickly as well that lends itself to making the Knative serverless much, much easier. And that is quite recently, I've been talking to the business unit, the guys that write this about this. I wanted to be able to deploy Knative serverless apps using Argo CD. Because at the moment, I'm using Knative function, or I'm handcrafting it, or I'm using the user interface. Because I'll show you very, very quickly before I show you the Argo CD stuff. But if I wanted to add another Knative service, so I'm going to build one from scratch. That's just for the hell of it. So if we go to Node, go to the builder image. What the builder image does is it allows me to give it a Git repo. It'll take a framework image, normally based on a universal base image, compile the code, produce the integrated component, integrated image, and then push it into the registry and then deploy it. However, because I've installed Knative Serverless, which installs as an operator and comes as part of OpenShift, I can now do this. So if I create, and I'm going to go for Node 16 on Rel 8 UBI, I'm going to give it a standard. I've got an application called OCP Node, which is a terrible application, which goes through to NASA and gets the image of the day, which is quite pretty. But if I scan down, you'll see I've got the component to be able to make it serverless deployment now. Just by ticking a box, I can make it serverless. And what this will do is it will do the source to image, do all those kind of things, but instead of instantiating it using a deployment or a deployment config, it will create a Knative service which puts all that stuff in place to allow you to actually create it on demand. I'll just put a different app group. I'll put the .NET app group just to really annoy people who've got OCD. And I'll create it. And what you'll notice when I start to create it is, if I just resize this box over here, bring it over here, go down out a bit. So what we got here, I'll bring it back in so you can see it, is this. It says no revisions, and this is very important. So what it's physically doing at the moment is building the image. It's going and get the framework image, building the source, producing the composite image, putting it into the integrated registry. When it's finished building it, it will deploy it, but it will create what's called a revision. Now, a revision is a temporary stamped instance of the Knative service. It's actually done it now. So I've got this one here and it's running. If we click on it, you'll see I've got revision called OCP node 00001. That is immutable. So once I've actually created it, I can't change anything that makes up that deployment. I can't change the image. I can't change the environment variables. I can't change the Knative service settings. And that's by design. And what happens is, let's say I want to change an environment variable. I want to change the number of replicas or make it scale up and things like that. It'll change the Knative service itself. When I do that, it will create another revision, but it will retain the original configuration for the previous revision. And then what you can do, which is really nice, and you'll see there's a little thing there saying 100%, is you can define how much of the traffic that spins up that application is sent to which revision. So if you've got, for example, a new version of your tiny little atomic service and you want to test it, you can actually create a revision in your Knative service and push 10% of the traffic in there. So 1/10 of the traffic will go into the new one, 9/10 will go into the old one. And that, like the root functionality within OpenShift, is dynamic and completely abstracted from the services themselves. So you can change the routing traffic, you can change that percentage without having to change any aspect of the revision whatsoever. That revision concept allows you to roll back and roll forward on the revisions you're actually providing to the outside world. So if you produce a little application, a little microservice, and you find that it's broken with the next release, or it doesn't do what it's meant to do, rather than having to wind it off, recreate, and do all those kind of things, you can just push the traffic back to the previous revision. And that's a nice little feature. The only downside of it, and I've talked to the business unit about this, is that it retains all the revisions. So you have to manually go and remove the revisions. Now, the only reason I found that out was I was did about 300 builds on one of the Knative services for the forum, and I had 300 revisions. So when I did an OC get service in my project, I had 300 Knative service revisions. So it was a bit excessive.
Yeah, there is still no automation that side, is just not to get rid of.
Not at the moment. There is the ability to limit the number of revisions you can have. But to be honest, most people are going to create one revision or two revisions and things like that. It's just one of those additional features in terms of Canary deployments that's really, really sweet about this. But again, this is now down to 0 because it's actually loaded, it's finished all I can. If I click on the actual URL, if we go back, you'll see it spin up. So this is going to actually bring it up, create it. There's a little pause, and there's a little tip for people using this. When you actually deploy your initial Knative service, set the initial replicas when it first deploys to the number of nodes you've got. And the reason for that is that it will then cache as part of the creation thing when it first creates it, because when a Knative service comes into life, it creates it first of all, then it scales it down. If you create it with a number of replicas that matches your number of worker nodes, you are 100% guaranteed that that image will exist locally on the worker nodes. And then when it scales down and scales back up, it's instantaneous. Because that little pause you saw then was it actually pushing the integrated image to the node and then spinning up the actual Knative service. So a little tip when you're doing this is to actually set the minimum number of replicas in the initial spin up to the number of worker nodes to make sure you get the image on every single worker node. While I'm talking that's spun up, if we go and look at it, I say it's a pretty appalling page. But if we go to JSON test, it goes off and gets the latest image of the day from NASA, which
wow.
Yeah, which I like. I used to work in the space industry, so it's one of my sort of like favorite things to play with. And if we pop back, you'll see that after a certain time, it'll scale down. You can set that initial default scale up and scale down time as well. So, but interestingly, and this is another one of those like niggly little things, the ability to set the initial timeout isn't part of the initial creation process. So when you create it, you then have to change the initial timeout, which creates a new revision. So I've been talking to the Knative service people about having that as an option for when you actually create it. This is all available through, there's a fantastic command line called KN, which is the Knative CLI, which allows you to interact directly with the Knative service components if you've previously logged on. So it uses the OpenShift or the Kubernetes configuration to log on to it. And that gives you the ability to actually change the revisions, to change the services, to do all those things at the Knative service level. You never really need to go into that, to be honest. You can use the interface, you can just tick that tick box, or you can actually do the Knative function thing, which does it all for you. Does that make sense?
Yeah, and I'd like to add that if you want to use the KN terminal and is available on your OpenShift cluster, you can download it from here, command line tools. But if you don't want to install anything, OpenShift also provides an operator called the web terminal operator. It's basically a component that adds to the web console, which is extendable, and you can have a web terminal, and this web terminal will contain KN as well. So I think it's very easy to try it out. Your demo, Knative, just with, downloading the KN CL, or using the web terminal operator. Just a note for people that want to try it out.
Absolutely. And going back to what I was talking about before I went off on a bit of a tangent there. What I've been playing with is the ability to actually set up Knative serverless through Argo CD. So, and I agree with Sebastian. I absolutely love the web terminal, and I'm ashamed to admit that I haven't installed it on this cluster yet. So that's the next thing I need to do when I finish this, because I absolutely love that web terminal. I used to produce. There is actually I produced a container that did it for demos, and it was a right nightmare to actually write that. So having it integrated fully, and the beautiful thing about the web terminal is the web terminal image contains all the latest instances of the command line functions, so you don't have to worry about being version confused. Anyway, so what I've got here is I've set up as a test the ability to actually deploy a serverless app via Argo CD, and all I did with that, and this is where it gets really sweet. When you define a Knative serverless, you just define the Knative service itself. Everything else is done for you. So the Knative service, for example, tells you which image to use, how to scale it up, all those kind of things you need to define the behavior of the Knative serverless. So what I've got, and I'll show you it, is if I go to my GitHub repo, if I go to a GitOps demo, I've got a subdirectory in here which I use for demos because I'm always recreating clusters, so I need to be doing this on a daily basis. And in here, you'll see I've got a customization file. And a customization file is like a shopping list, and that tells Argo CD what components have to exist at the target point to implement this application. In this case, it's a broker, the K service itself, and the trigger that causes the traffic to actually get into the K service, Knative service. If we go to Knative serverless, the broker definitions are beautifully simple. And very quick point on this. Those brokers, the things that actually send the cloud events, they are ephemeral. So what that means is when an event arrives at the broker, it will scan its list of triggers, it will push the event down the trigger to cause the Knative service to start, and then it discards the actual event. So they are completely ephemeral. But what you can do is you can back them with what's called a sync. So a couple of examples I've seen, really fantastic ones, is a broker being backed by a Kafka topic. So you've got a Kafka topic, which is actually driving the cloud events into the broker. And the beautiful thing about that with the Kafka is, of course, you can temporarily replay it. So you can go back and you can wind that Kafka topic back and then replay those events through. So you can do persistence within the broker itself. But you can see out of the box, very, very simple, single line, kind broker, name default. We go and look at the actual service. The service is slightly more complicated because what I've got here is basically I'm using the Knative functions. So what I'm doing is I'm actually using, we'll scan down here. There's an image I pre-built, which is tech talk function on key.io. I've got a couple of environment variables I'm pushing in and some labels, which actually set it up as a Knative service. And all I do is I push that in. This container concurrency indicates the scale down value. So that's scaled down to 0. The third component I add through the Argo CD is the trigger. And the trigger simply links the type to the subscriber. In this case, it's a service SVC test 1. And SVC test 1 is the actual Knative service. So basically what the trigger does is it links that service to that event type. Now, very quickly on the cloud events, because I've written a blog on this, but it's really interesting. The cloud event has basically a type and a source, and the source is basically a label from which that thing is actually being driven, and the type is the actual physical type that's used to create the trigger. It also has a unique ID. So what it does in the system itself is it combines the unique ID and the source to make a unique cloud event ID. And you have to be aware of this. And the reason you have to be aware of it is that is used as a unique indicator as to whether or not the broker actually processes it. So if you've got, for example, an application that's throwing cloud events and it's called My App, and you set an ID to 1. When you send that into the broker, it's distributed. If you then resend that event with the same ID and the same source, it's not processed because it's defined as being a unique ID by the combination of those two together. So just be aware of that when you're playing with this, where you have to have a source which actually identifies where the event is coming from and an ID which is unique. But I put these 3 pieces of YAML and the customize into a GitHub repo. I've then created an application within Argo CD, and it will automatically deploy all the components I need to stand up that serverless application. In fact, I'm feeling pretty brave, and we've got a couple of minutes. I'll create another one from scratch just to show it working. So if we go into applications, we'll go to new app. We'll call it Demo Gods Hate Me. Default. I give it the source repository, in which in this case it's the GitHub repo where my example lives, GitOps Demo 1. And the path is serverless test 1, I think. I'll just check that to make sure, I'm not being silly. Sorry, serverless 1. So we'll go back and make it serverless 1. Serverless 1. Then I need to choose the cluster default, and I'm creating a new namespace for it so I can show you it actually working. So if we go to the administrator side, go to home, go to projects, create a project, my new project, that's right. Created that, go into Argo CD, and I'll put it in my new project. And just to show there's nothing up my sleeves, if I go into here, go into developer, go to topology, no resources found, there's nothing running in there whatsoever. Go to Argo CD, set the customize to default, so it's just going to pull it, it's going to recursively use the customized file to push those things onto it, and create. So we got it here, healthy. It's out of sync because I haven't synchronized it yet. I set it to default to do manual synchronization because I want to actually show it not being automated. So I hit sync. So what that now does is it goes off and it pulls the actual information from the GitHub repo and creates all the bits I need. If I pop back, you should see them start to spin up instantly. So I've spun up my broker. I've spun up my Knative service, which is actually instantiated a single copy because it always creates a copy initially to make sure everything's working fine before it offlines it. So that's now running in there, sat there. After the timeout expires, this will spin down to 0. But you can see how simple it was. I just created an Argo CD app and pointed it at that GitHub repo that contained that YAML. And I'm going to write a blog on this because I think this makes actually creating Knative services and maintaining them a lot simpler as well. I say I've now gone off on a bit of a tangent.
This approach really lowered the barrier for developers when they approach the Kubernetes world, which is sometimes could be challenging, as we know. And just one question before, because I would like to hear from you more from about these great stuffs, but time is the end is approaching. You use a lot of the terms function, Knative function. For the ones that are not so used to manage or to deal with the Knative world, what do you mean, or what do we mean in Red Hat when we speak about Knative function, really, from a practical perspective?
Knative function is an even easier way for developers to produce Knative services. What we've done is we've rolled in the kind of creation of the image, the deployment of the image, the creation of the Knative serverless components into a single command line. And what's nice about it, I'll show you an example of this very, very quickly. So if I go to, I drop into my Quarkus function directory, oops, you'll see that I've got a file in here called func.yaml. So if I cat func.yaml, what it is when you run the kn function, it uses the func.yaml to actually describe exactly how it wants the Knative service to be deployed as a function. And if we look at it, you'll see that it has a number of different things that are really, really cool, make it really, very simple. It basically defines the runtime. It defines the image I'm going to push to, because this actually compiles and builds the image itself. It defines the actual type of Knative service. So am I going to be driven by what's called serving when traffic ingresses in through a URL, or am I going to use the event model where it's driven by a cloud event? And then it defines the builder. And these builders here are actually pre-built build packs that will take your physical source and actually build it. Now, what you'll notice here is that it doesn't have a description of the source, because the actual func.yaml, you execute it in the directory where the source is. So you're in the actual directory itself, and I've got a func.yaml and a pom.xml if you're doing the Quarkus one. When you execute the kn func, it's called, it will actually read this configuration file, compile the code within the directory, build the image, deploy the image, set up the Knative serverless, do everything you need to do. And all you need to do is to type kn space func. And it makes it so much simpler. And we've got, the nice thing about the function stuff is it supports Java with via Quarkus, Node, Go. I think there's a Python one at the moment. So there's a number of different language selections you can use, and it's based upon the build packs that are provided. It's still reasonably new technology, and we're still building it. But for me, it's going to be really nice because you'll just have to run a single command line, and bang, it does everything for you.
Cool, really cool. Yeah. Thanks.
Yeah, that's pretty cool. That is do you know, Ian, how we can, because I know this comes from Boson project, where basically we merged Boson project to Knative. And do you know how we could do what you say, like we can make an automated build of the function? Because at the moment it's a Docker build locally. Do you know if on OpenShift we can trigger the function build with build v2? Do you know how it's going to work?
Yeah, when we actually produce build v2 and we actually integrate Shipwright into OpenShift, then what will happen is, because what happens at the moment when you run kn func is it builds it locally. It's quite difficult for me because I hate to admit this, I have a Mac. Even though I work for Red Hat, I have a Mac. So I have to run it in a Fedora virtual machine or a RHEL virtual machine to run Podman to actually build it. What we're going to have with the build v2 and Shipwright is the ability to build locally on the cluster. And we've actually, this is where it gets even nicer. We're going to be able to actually build it into a Tecton pipeline, because the Tecton pipeline has a cluster task called builder, which executes a Podman build within the cluster itself based on the build packs. So there's going to be a lot of stuff coming where you could, because you could do it today by actually setting it up and running it on the cluster using a builder task within the actual Tecton. But when we release build v2, it will be integrated fully into OpenShift. So you'll be able to do your builds on the cluster itself. So all you will have to do is actually write your code locally, or even write your code in something like developer workspaces, and then submit it, and bang, you can do it on the cluster.
Great. That's great. That is something really implementing function as a service in the platform.
Yeah, as a final thing, because we're running out of time, I put this link up. There's a GitHub repo called Kneural on my Git repo. It's a work in progress, but this is where I'm actually putting all the stuff to do with this atomic decomposition stuff, because we got a little bit into the philosophy of that, and I think that that's massive in terms of the way that we can write applications going forward. I think it's the way we should be doing it, but I've still got to nail it. It's not quite there, but it's a work in progress. Anything I do will be put up there.
We put the link in the chat, and also there's the caption, so you can see this is the link for the K-Neural project, which is really cool. Also, technical and architectural speaking, is another approach to neural network. So it's interesting.
Today was.
Sorry, Carol.
So please go ahead. Sorry.
The nice thing about this repo is it also contains a lot of YAML for building the actual InfiniSpan data grids. So that was one of the first problems I had in actually using the data grid operator within OpenShift. So there's a lot of example YAML there about how to spin up the operator, how to set up the data grid to execute appropriately within OpenShift. So there's some nice features in there as well.
Okay, cool. We had today a really global session. Natalia, so people joining from Australia, New Zealand, I read, Auckland, great place. So
so Ian, your talk was attractive to globally attractive.
It's always nice to be appreciated.
So there's a great from European session to global session. Okay.
Thank you very much, Ian. I think it was really great session. And for people that would like to watch it again, the recording is on the same YouTube link, or you find it on Twitch. On YouTube, it's going to be permanent in our OpenShift TV coffee break playlist. And I like your t-shirt. I think this is a smaller one, but I have the OpenShift 4 here.
Mine's blank on the back. I stole mine from marketing.
I mean, the one with not the right t-shirt. Sorry, guys. I just.
But you are in the office.
Okay, but I think the issue is that this morning I just picked up the first one from the closet. So
First in, first out approach. Well, Fabio, let's wrap up everything. First, thanks, Ian, for this great session. We understood more what it means creating an intelligent or AI/ML driven app dev, next generation, so serverless or scale to zero or on demand or event driven. I think they are all valid pattern. And we also discovered that this your project, which is the K-Neural, which is really interesting that we shared in the chat. We have some appointment for the next session. Today you have the OpenShift TV shows in the schedule in our afternoon time, and Fabio, we come back next week, Wednesday, same time. And any final reminder?
No, just thank you again, Ian, for your availability, for a great session. It was great.
Cheers, thanks.
Stuffs I learned. So when I learn something, I mean, that's a great thing.
It's always fun.
I think.
Always. And Ian, you have to come back because I'm sure you have more and more cool live demos. We really enjoyed this one.
We will ping you soon. Yeah, definitely. Yes.
Super. Yeah, definitely up for that.
Yeah, people that want to connect with Ian, you find it on some people ask the name. You find it on LinkedIn. You can interact and add and talk with him. You find it also in Red Hat conferences. What's your next conference?
I think it's going to be the Summit Connect.
Summit Connect in UK?
Yeah, I think it's late October.
Okay. So people interested in seeing the in-person, Ian, you find it at Summit Connect UK in October. I don't know if you have any link.
We also run an OpenShift London UK meetup, which we do once a month.
That's interesting.
Yeah, I'll find the URL for you. It's on the meetup.org, and I tend to present at most of those.
That's great to hear. The London OpenShift user group. Yeah, that looks this one. So people interested in the area, please join the meetup in London area. And
it's always good.
Folks, thank you very much, and see you next Wednesday. Have a good day. Bye.
Thanks for having me. Cheers, guys.